Hey everyone, and a huge welcome to all our Grade 7 programmers out there. You're tuning into the Explainer for Lesson ID, STEM-Python-STEM-Python Unit-06-Lesson Pack-01 Functions-Application Task Video Overview. And our exact title today is Functions Application Task Video Overview. We are officially kicking off Unit 06. This unit is literally all about functions. So today, we're going to untangle exactly how they operate under the hood in Python. Grab your thinking caps, because we're getting right into the logic.
Section 1. The Great Function Misconception. Let's look at some common beginner mistakes.
Okay, let's dive into this. Have you ever written a fantastic new piece of code, like a beautifully named function, you hit run and absolutely nothing happens? Or maybe you try to get a result out of your function but just got an error instead? Well, don't worry, you are definitely not alone. This brings us to a classic stumbling block for beginners, and we really need to clear it up right away. See, a lot of students mistakenly believe a function just runs automatically the second it exists in your script, but it doesn't. The other major mix-up, confusing a function's parameters, which are the things going in, with its return value, which is the data coming out. Inputs and outputs are completely different jobs in Python.
All right, moving on to Section 2, Evidence, Python Function Rules. To solve this mystery and build a really rock-solid foundation, we're going to look at the official evidence, returning straight to the source, the official Python 3 documentation. You can basically think of these docs as the ultimate rulebook for how control flow and compound statements actually operate when your computer runs them. Now, according to Section 8 of the docs, a function is what Python calls a compound statement. But what does that actually mean in plain English? Well, a compound statement is just a construct that spans multiple lines. It's got two main parts. First, a clause header, which starts with a unique keyword and ends in a colon. Second, a controlled group of statements, which Python literally calls a suite. Think of the header as setting the stage, while the indented suite below it is the part that does the actual work.
Let's see how this builds. Section 4.8 of the documentation outlines the exact structural anatomy of defining a function step by step. Step 1. We start the header with the def keyword. Step 2, we provide the function name, and that's immediately followed by a parenthesized list of formal parameters. Step 3, we lock that header in with that all-important colon. And finally, step 4, we move to the next line and indent our suite. That indented body, that's the core logic of our function. And remember our misconception from earlier? Just defining this structure doesn't actually run it, it just builds it. It associates the function name with the function object, and then it just waits to be called.
So the absolutely crucial point here is understanding what happens when we actually execute or call that function. When a function is called, the actual arguments you provide are passed using call by value into a brand new local symbol table created just for that specific function execution. Those are your parameters going in. Okay, then how do we get data out? Well, the return statement returns with a value from a function. It sends the data back. Now, if you have a return statement without an expression, or if your code just falls off the end of the suite without a return statement at all, Python quietly outputs a built-in value called none.
Okay, Section 3, Tracing a Worked Example. Let's see this in action step by step.
Now that we've successfully decoded the official Python 3 documentation, let's apply these rules to a highly stripped-down, completely Grade 7 appropriate piece of code. What's really interesting here is watching how the data flows in and out. Take a look at our code definition. We have def add numbers with a comma b in parentheses. Inside the suite, we have return a plus b. Then below all that, we actually execute the function with result equals add numbers 3, 4. When this call happens, our arguments, the numbers 3 and 4, go into the local symbol table to become the parameters a and b. The suite evaluates 3 plus 4. And finally, the sum of 7 comes out via the return statement and gets stored right in our result variable. It's that simple. Arguments go in, return values come out.
Moving to Section 4, Application Task. Your turn. Time to put you in the driver's seat.
All right, Grade 7s, I hope you have your coding brains fully engaged, because it's time to put this logic into practice yourselves. Trace this code, def multiply by 2x, and then inside the suite, return x times 2. My question for you is this. What is the return value of multiply by 2, 5? I want you to go ahead and pause this explainer right now, challenge yourself to trace the parameter going in, and figure out the exact return value coming out based on the rules we just covered. Go on, hit pause. I'll be right here waiting.
Welcome back.
Let's see how your trace matched up with the official Python rules. And this brilliantly illustrates our core concept. When we call multiply underscore by underscore 2 of 5, the argument 5 is passed to the parameter x in the local symbol table. Next, the suite evaluates the expression 5 times 2, which of course gives us 10. Finally, the return statement executes, sending that data back out. The function returns 10. If you trace that perfectly to 10, phenomenal job. You officially understand the flow of data.
Bringing it home now. Section 5. Final function takeaway. The golden rule.
We've covered some absolutely fantastic foundational ground today, relying strictly on the exact definitions provided by the creators of Python themselves. Let's wrap up this explainer by summarizing our lesson into one easily remembered golden rule. You might want to write this down. Parameters carry data in to the local symbol table, and return statements send data out. Remember, defining a function is really just building the machine. It doesn't run automatically just by existing. And most importantly, the inputs you feed into it are fundamentally distinct from the outputs it hands back to you. If you keep those straight, you're going to master functions in no time.
Before I let you go, I want to leave you with a bit of a provocative thought experiment to ponder. If a function returns a value, can that exact return value immediately become the parameter for a completely different function? Think about how you might, say, chain functions together, using the output of one as the input for another to build incredibly complex programs out of simple, easily understood blocks. Keep that curiosity firing for your next Python lesson. Thanks so much for learning with me today on this explainer,